progress.
Welcome back to my online video tutorial series. At the end of this video, you should know how to find the shortest distance for two skew lines. To find the shortest distance on two skew lines, our main objective is to find a point where both lines are parallel. Both lines are parallel. To do that, the first step is to draw a line. Choose one line. We could choose either line AB or BC. And if you're doing it in AutoCAD, you would copy. You'd copy AB line at A and place it here. So we're gonna place it here to produce a parallel line. So that's the first one. Whatever is done, so first thing we copy this line from here to here to get it parallel, to get AB parallel to that line. Whatever we do on the front plan, we must do the same. Whatever we do on the front, we must do the same on the plan. So we copy, we draw a parallel line to AB at point D. We must also draw a parallel line to AB1 at D1. So we copy here in AutoCAD, or for drawing using pencil, we'd use our set square to do that. So this line is parallel to that. This line is also parallel to that point. Our next step is to draw a horizontal line at point C, horizontal line at point C. At the point where this horizontal line cuts the parallel line D, we label that point O. So label this O, label this O. O. We then draw a vertical line down from point O. Vertical line down from point O. At the point where the vertical line cuts the parallel line on the plan. Remember, here is the front elevation, here is the plan. At the point where the vertical line cuts the parallel line on the plan, we label that point O1. O or O prime. Or the true length here, the true length of this is CO on the front elevation. And the true length on the plan is from C1 to O1. So our next step is to draw a line from C1 through to O1 and extend this line outward. So we draw a line from here, extend it through C prime, click there. Our next step is to use this line as our reference line to draw a parallel line through all the ends. So we have one parallel line through here, one there. So we go back to line. We start at A, click here. Let me use a different color for this. Different color. So we click here at A and we draw parallel line relative to line C1, C prime, O prime. We go down to B, and in like manner, we draw a parallel line here. We then go down to D1, D prime. Then we draw a parallel line here. In AutoCAD, we would use copy to get the parallel line. If we're using set square, we would align or join instruments and the relative to C101 to draw to get those lines. And of course, we have C101 already. So these are all 4 sides. Our next step is to establish our auxiliary view. All right. So to do that, to establish our auxiliary x1, y1, we draw a perpendicular line to this line. And of course, I'm going to change the color and the line width thickness. So I choose to start I could start up here. So I choose to draw my x1, y1 here. Here is x1, y1, y1. We have x1, y1. Our next step for auxiliary projection, to draw the auxiliary projection of a figure, we normally step back 2 views. So we are working on this view. This plan view is 1. So we take our measurement from the front. All right. So again, to draw the auxiliary view, we always step back. Auxiliary projection, we always step back 2 views. So in this case, we are drawing here. So we step back 1, 2 view. It means therefore that our measurement is taken from C to x1 line, A to x1, or a distance. We're going to transfer these distance, the distance from A to x1 on A1 x1 line. So this is A1 x1. So we go up. Here is our reference point. So change the color of my line to something different, probably brown line. So I go back as I locate this. The distance is here. This is the distance. This is a distance. So I transfer this distance onto line A. So let's use this. So I start here, transfer this distance onto that line. That's a little too much. And this now becomes A2. So I label as I go so as not to have any confusion. A2. Right. I now go across the line to B and transfer B, the distance from B to XY. Right. B to XY. So I go across I track B. So this is B. B is here. And the starting point is here. And I try to get the same distance there. So you would use actual measurement to get that. So this seems to be B1. And of course, I label as I go. B1, B2, sorry. Our next step is to draw the first parallel line. So for that, I'm gonna change the color of my marker. Let's use red. And I go back to line. So I draw a straight line from here down to here, this point. So this is my first parallel line. I am gonna change to is it same burgundy? Yes. Change line width thickness. No, I'm gonna focus on line line A, B, C, D. Again, I transfer the distance here from XY, from XY up to C on the corresponding line. So I go here, this is line C, I trace it up to here, I start here, and I try to get the same distance here. All right, so this seems like it. I click there, and of course I'm going to label it same time. This is C2. I then go down to D, go down to point D, and again I'm going to transfer this distance here on D line. So where is D line? Oh, look what I did here. I drew A on the wrong line. So I made a mistake there. So let's correct this. So this is A. That should have been A. So I'll need to erase this. Erase. And redraw my line. It's okay. You'll make mistake. So from A to B. That's A to B. Yes. B line, A line, A to B. Right? So I would need to correct this as well. Text. And this is A2. Our next step is, I need to label this as well. This is D2, back to text. This is D2. All right, we have C2 and D2. Our next step is to join C2 to D2. And this should give us a parallel line. If it doesn't produce a parallel line, something is incorrect. So again, I go to line, join C2 to D2. Yeah. And that is my parallel line. So these two lines should be parallel. No, the closest possible distance is a perpendicular distance across these two lines. All right, across those two lines. So to do that, we simply draw a line perpendicular to this. Change my color. So we draw a line perpendicular to this. And then we would measure this distance here, measure from here to here. And that is the shortest possible distance. That's how we get that.